So A be a 2 cross 2 matrix, and we have defined a map. Okay, so we have defined if x comma y to be y transpose ax. Okay, so what should be our approach? So what should be our approach? Hmm. Any ideas? So suppose A is A transpose, okay, and A11 is greater than 0. So A will be the matrix like this. So I am putting just some constant here since they are equal, huh? The symmetric matrix. Okay, so let's see whether this is an inner product or not. Okay, so one thing I hope you can check, that suppose okay. Similarly, if a x y plus z is Okay. Hmm. And also if A is lambda x, these things you can check. I think it will be lambda fx, and also in the second component these things you can check. The main thing which I want to check is fa x comma x greater than 0 for all x belongs to R2, right? That should be our concern. So write it. So suppose x is like x1 x2. Hmm? So what is fa x comma x? That is x1 x2. So anyone, what will be this expression? Please check the multiplication. Okay, so this is the multiplication, right? So we will have to show that this expression is always greater than 0. Okay, so how can we prove this? There is nothing much in it, just a little bit of manipulation. So this is, This is the expression. Okay. So as you can see, this thing is greater than 0, right? So this is nothing but okay. Each of these terms are greater than 0. Okay. And the opposite. Now, if a xy is an inner product, then what happens? Then let's see whether these conditions are satisfied or not. So you can take x to be 1, 0, and you will realize, like I had written down the expression here. I had written down the expression here. This expression. It will look like this. You will realize this is the expression. Okay. Now, if you put x equals to y equals to 1, 0, you will get a 1, 1 greater than 0. If you put x equals to y equals to 0, 1, you will get a 2, 2 greater than 0. Since this is an inner product, Since this is an inner product, so this will become f a x comma x. So since it is an inner product, it is supposed to be greater than 0. And for the determinant part, you just can take x equals to y equals to 1 minus 1. Okay. Then you will get determinant a is greater. This is the column for just f a x comma x. Okay. These sort of matrices are called positive definite matrix. We will come on to these things in a few classes. Let V be a real or complex vector space in an inner product space. Okay, 9. Can you do 9? Any one of you? 9? So V be a real vector space so that the quadratic form determined by the inner product satisfies the parallelogram law. Okay, let's see. Hey, this is not much. I mean, I hope you can do it yourself. Just put this. Just do this and expand. Okay, you can do it yourself. Those who are math aspirants for like Raghiv, Ishan, Shubrita, these classes are extremely important for you. Ten. What was the inner product of example 2? What was the inner product in example 2 by the way? Hmm. So beta is like this. I don't know whether you remember or not. Just write down this matrix. A equals to Aij, huh? Where Aij is nothing but inner product epsilon j epsilon I. Just compute the matrix, nothing. Compute epsilon 1, epsilon 2, hmm. inner product of this epsilon j epsilon I, compute it and just write it in the as the gith entry. That's it. That's how that's how we compute an inner product matrix, right? I mean, by definition, that is the inner product matrix of that particular inner product. Hmm. This is a very good. Try 11 for 2 minutes, 2 3 minutes. Try 11. Hello. বল। আমাদের ক্লাস নিচ্ছে না। হুম, 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 হুম। আমি তাহলে কোথায় যাবো? হ্যাঁ, ঠিক আছে। এরপরে সাথে কথা বলবো? হ্যাঁ, কথা কেন হবে না? আমি এটা নিয়ে কিছু বলিনি। হুম, 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 হুম। ওর ব্যাপার একই, ঠিক আছে? ও মানে ও হয় আমার বাড়ির সামনে দিয়ে গিয়ে বাইপাসে উঠবে, অথবা হাটখো দিয়ে গিয়ে বাইপাসে উঠবে, ব্যাপার ওর একই। হুম, ঠিক আছে। এই দেখ, একটা ভালো ডাক্তার পেয়েছি, ঠিক আছে? ডাক্তার একটা ভালো পেয়েছি। এই রুবিতে বাবার ওয়েস্ট বেঙ্গল হেলথ স্কিমও আছে। এই কৃষাণুর স্যার সুমনলাল সিনিয়র। তো সুমন দা অলরেডি তার সাথে কথাবার্তা বলে রেখে দিয়েছে, একদিন তো পাঠাচ্ছে তোমার কাছে। তো উনি টাটা মেডিকেল সেন্টার আছে না মুম্বাইতে, যেটা সব থেকে ভালো, ওখান থেকে উনি পিএইচডি করে এসেছেন, ডিএম। হুম। তো ওনার কাছে দেখাতে যাবো রবিতে মঙ্গলবার। আর ওনার কাছে দেখানোর আগে শনিবার দিন ওরা একটা অঙ্ক বোর্ড বসায়, মানে ওদের বোর্ড বসিয়ে ওরা দেখে পেশেন্টের কন্ডিশন কার কাছে পাঠাবে, সেটা হচ্ছে শনিবার আছে। হুম। না, সে সকালে, শনিবার সকালে চলে আসে। রোববার থেকে পড়ানো। কোনো শরীর খারাপ নেই, কিচ্ছু নেই। বাবার শুধু সমস্যা হচ্ছে যে উঠতে বসতে ব্যথা করছে মুখে, মানে পাঁজরে। এছাড়া কোনো সমস্যা নেই। বিপি আছে ভাই, ওষুধ খেলে না তুমি? এটার জন্য দেয়নি, আগে গেছিল তো। ডাক্তার তো খুবই খুশি হয়েছে। সিরোসিস নিয়ে ডাক্তার তো খুবই খুশি হয়েছে। এই তিনটের মধ্যে তিনটে মেন ওষুধের মধ্যে দুটো নিতে পারলেন, তারপরে হিমোগ্লোবিন 9.7, তো বাবার এন্ডোস্কোপি কোলোনোস্কোপি ইজি করে। আচ্ছা, এগুলো সম্বন্ধে তো বলিনি, হ্যাঁ, যে এন্ডোস্কোপি কোলোনোস্কোপি না না, সুমনদাকে বাকি সবই বলেছি, ভালো হতে বলেছি, এন্ডোস্কোপি কোলোনোস্কোপি করেনি সেটা বলিনি। আর এখানকার ডাক্তাররা না ভাবে যে সমাধানটা করতেই হবে, ঠিক আছে, নাহলে খুব সমস্যা। আমি ইচ্ছা করি বলি। হ্যাঁ, আমি তো কিছু করতেই হবে, আমরা হিমোগ্লোবিন রিকোয়ারমেন্ট নিয়ে কি ডাক্তার বলছে না কিছু করতে হবে। হুম, 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 হুম। এটা আসলে দিন ক্লাসটা করিয়ে নিই, বুঝলি, ক্লাসটা করিয়ে নিই, অনেকদিন বাদে ক্লাস নিতে বলেছে। বলছি অনেকদিন বাদে ক্লাস নিতে বলেছি, বুঝলি, এই ক্লাসটা করিয়ে নিই। Okay, let's try. Okay, so okay, so we have already seen that this is an inner product, right? We have already seen that if what should I say? If C01, that is the vector space of all continuous functions from 0, 1 to R, then on C01, if inner product G defined by 0 to 1, if T dt, we have already seen it that this is an inner product, right? Now, think Rx to be a subset of C01, because every polynomial is of course continuous. So we can think it as a subspace. Now, if G belongs to, another thing we know that this is also a basis of Rx, right? So if G belongs to Rx, you have like these two polynomials, like fx will look like summation j. Okay, so if G, so what will be F inner product G? So this will of course be AJ, BK, x to the power J, inner product x to the power K, right? And what is it? AJ, BK, integration x to the power J, x to the power K, 0 to 1 dx. This is x to the power J plus K. So by integrating this, you get just AJ, BK by 1 plus. Okay. So you get that this thing is an inner product, right? This is nothing but an inner product written in this way. Okay. So, so this is the solution basically. Okay. 12. V be a finite dimensional vector space and theta alpha 1 to alpha n be a basis for V. Be a basis for V. Be any scalars so that. Okay. Try 12. 2 minutes you have. Ma Okay, let's try 12. That's the beauty of Hoffman Kunja. I believe the problems are very good and these problems are also doable, unlike some other books. So V is a finite dimensional vector space, beta is any basis, show that there are exactly okay. So what should we do? What should we do? So let G be the inner product matrix of this. I mean, ah, ah. Okay. For any beta belongs to, I mean, for any beta is any vector, huh? Small beta, we have what is beta in our product alpha j? Correct? By linearity, this is nothing but right. So let alpha equals to summation xi alpha. Okay. If alpha satisfies it means Gji is equal to Cj, right? Right? By this, hmm? By this, no? So what do we need to do? This is a system of equation, no? This is a system of linear equation, right? So you need to solve this. Just write down the inner product matrix, right? This is C1, Cn, okay? You need to solve this. And we know that. And what is that? What is that? There is a unique solution, isn't it? If this matrix is G, it is just G inverse this, right? Unique solution, na? Because this is a full rank. Okay, so done. Now let's do 30. So, see, you know about one conjugation, right? Like C going to C bar. Huh? You see, they are giving a generalized definition of a conjugation. Okay, it is a generalized definition. Just look at the definition. Okay, so how to solve this problem? So complex vector space. So see, we have already defined like the complex number C. They are giving a similar notion, I mean a conjugation on C, but they are giving a similar notion on any C vector space. J alpha plus J beta J C alpha C bar J alpha, like if J is a conjugation, show that there are something so suppose alpha beta belongs to W and C belongs to R. So J C alpha plus beta, this is J C alpha plus J beta by this formula. This is C bar J alpha plus J beta, but C is in R, right? So C bar is C. And J alpha is alpha and J beta is beta, because that's how W is defined. So W is a vector space, real vector space, okay? Now, they are trying to show that for every alpha, there exists unique beta and gamma such that alpha is equals to beta plus I gamma. Okay. So you can check that this will work. Okay. So you will see that alpha equals to beta plus I gamma. Now, one thing should be a natural question. How do I come up with this? How do I guess the right beta and gamma? Okay. See, the trick is like this. So think alpha belongs to C. Hint. This is just hint. Now, how can you write alpha? It is like real alpha plus I imaginary alpha, right? What is the real part of alpha, by the way? Alpha plus alpha bar by 2, right? And what is imaginary part of alpha? What is imaginary part of alpha? Okay, right? This is the one now. So they have just put alpha bar instead of j alpha. Okay, so that is the intuition. And for uniqueness, this is easy actually, because I mean, if alpha is beta plus I gamma equals to beta prime plus I gamma prime, then you have beta minus beta prime equals to I gamma prime minus gamma. So this is sorry. Uh, yeah, I mean just right. This implies beta equals to beta prime and gamma. Take V as a R vector space. In this line, we are basically considering V as an R vector space. So this is sort of, I mean, if say V is C to the power n, right? So we are sort of considering this to be R to the power n direct sum I R to the power n, okay? That's the breakup here. Understood? Understood? Okay, so let's move to 14, right? Yeah, 14. Hmm. So how do we approach this problem? Vector space and W is set of V, a subset of V is the following property. Is a real vector space with respect to the operations defined on V. For each alpha in V, there exists a unique vector beta and gamma in W such that alpha is beta plus I gamma. Show that the equation G alpha equals to beta minus I gamma defines a conjugation on V such that G alpha equals to alpha if and only if alpha belongs to W, and also show that J is the only conjugation on V with this property. Okay. So one step is easy now. Check that J alpha plus beta is J alpha plus J beta, and J C alpha is C bar alpha, C bar J alpha. These you can check. These are elementary check. So that for each alpha in V, there exists a unique vector beta gamma. Okay. So if alpha belongs to W, we can write alpha to be I. Okay. But from B, from condition B, this is the unique choice, right? This is a unique expression. Thus, J alpha is alpha. If alpha belongs to W, then we write, okay, so I mean, we should be writing like this. Huh. So, I mean, G alpha should be this, na? But alpha has already been written in this way. Now, conversely, if J beta plus I gamma if this defines a conjugation, and if J alpha equals to alpha, then what do we have? We have beta plus I gamma equals to beta minus I gamma, where alpha is beta plus I gamma. So you get gamma is 0. Which means alpha equals to beta belongs to W. Again, this is because of that a condition B. There exists unique expression beta and gamma such that this happens. Okay. Now, for the uniqueness. So, suppose there exists another conjugation J prime such that J prime equals to alpha if and only if alpha belongs to W. So then what do you have? You have J prime alpha equals to J prime beta plus I gamma equals to, by the conjugation property, you have J prime beta minus I which is J alpha. Okay, so this is unique such map. Let's do okay, let's do 15. We are told to find all conjugations on C1 and C2. can we use 14 here? Okay, so see, on C1 we have just a conjugation C going to C bar. On C2, this is like C1 C2 going to C1 bar C2 bar, and they are the only conjugations. These we get from 13 na? Okay, because for this the W is R. For C2 the W is C1 comma C2 if C1 comma C2 both are in R. Okay, as I told you, like C2 can be written in terms of R2 dx sum IR2. That's what they are doing. This is the W. Okay, let's try 16. See, understand C question. Don't think that these are two same vector spaces. Like take R, take C. 1. This is a basis of R, right? 1 is also a basis of C. That's the key here. If you take like C square, and I told you this is like R2 direct sum IR2. So what is the basis here? Say 1001. Okay. Now these will be basis in C square as well, because to span this you just need to multiply these vectors by I. So you don't need new basis elements because there is an extra scalar I which will compensate for it. Okay. Okay, try 16 for 2-3 minutes. Try 16 and 17 for 5 units. Okay, let's do this. So 16. So suppose alpha 1 to alpha n is a basis of W. So for alpha belongs to V, we know that that is also a basis of V. So first we are assuming that this is a basis of W as well as V. Now let's see whether W satisfies the condition B of exercise 14. So we can find unique C1 to Cn belongs to C such that alpha is summation Cj alpha j. Write this Cj as Aj plus I Bj. Okay. Now denote. See, understand this thing. I mean, what is the alpha? What alpha does become then? It becomes summation Aj alpha j plus I beta j alpha j, right? And naturally, this is the real part sort of thing. So denote beta by summation Aj alpha j and gamma by summation beta j alpha bj alpha j. Then alpha is just beta plus I gamma. Okay. Conversely, if alpha 1 to alpha n is a basis of W, and suppose it satisfies that given condition B of then for any alpha belongs to V, there exist beta gamma in W such that beta plus I gamma. Now see, this is a basis of W, so beta is summation Aj alpha j and gamma is summation, these are in W na, so this is the basis of W. What should I say, Bj alpha j maybe. So again alpha becomes summation Aj plus Ibj plus alpha j. Okay. So this means alpha 1 to alpha n spans V. Check the linear independence. It is not very difficult. Check it. If you don't do it, then let me know if you can't do it. Just take a linear combination, then just break it into real and imaginary part. That's the key. Okay. Now let's move on to 70. So V be a complex vector space, J conjugation of V, W the set of alpha in V, sorry that J alpha is alpha. If is an inner product on W, show that there is a unique inner product G on V such that hmm. So if is an inner product given on the real part of V, right? So see, okay, I will show you the trick. In C, what do? You do like this. Suppose A plus IB, C plus ID. Okay, and what does it turn out to be? A inner product C. These are real inner product, huh? On real plus. Tell me what is this? I B inner product C plus minus I A inner product D minus. So keeping that this idea in mind, just replace this by G and this the real inner product by F. That's it. So you take G alpha beta, or maybe I should write G alpha alpha prime. Yeah, write alpha alpha prime. G alpha alpha prime, where alpha is beta plus I gamma L, and this is beta prime plus I gamma prime. So what will it be? You have already F. Okay, define F to be F beta beta prime plus I F B C. So B C gamma beta prime minus I F beta gamma prime minus F gamma. That's it. Okay, so this check I hope you can do. And that G alpha plus G beta. So this was A. For B, J alpha J beta. Okay, I mean take alpha to be A plus IB and beta to be C plus ID. So J alpha becomes A minus IB J beta becomes C minus ID, and you can check. Okay, just put it here. It's a basic check. This is just GBL. And what is the intuition here? Nothing. This is just like alpha bar beta bar is just beta alpha whole bar. This is a generalization of this. Huh? So basically we can extend the whole idea of complex inner product to C to the power n. I mean any finite dimensional vector space over C as well. Okay. So that's it for today. In the next class we will start this inner product spaces, these inequalities and all their stuffs. Let's see how far we can go. Okay. Bye. এই সুব্রিতা এটা কত নম্বর ক্লাস?
20